Hello everyone. In first module, we have seen basic services of AWS. For example, introduction of the AWS web service, what is the cloud, what is the hybrid cloud, and all those topics. So what we are doing in the normal every module that first we discuss the concept of the module. Then we try to create the documentation for each module plus the real-time questions that could appear in the practitioner test, which is very realistic. And we try to solve them that which option was what. And in the final step, we need to perform, or we sometimes perform it on the AWS console in real time to make sure that you also practically do it from the other side. So just to make sure that the practicing it on AWS console is not necessary. It is necessary at the associate level, but at the fundamental level or the practitioner level of the AWS, you just you must need to have understanding of the concept. But performing it on console gives you more confidence, so that's why it's necessary, I think. That's why I normally do it. So that's how we do it. Let's start module number two. Module number two is all about the computation power at AWS. Computation power is nothing but a simple computer. Whatever computer or laptop we are using at home. It is very similar computer, but kind of distributed or connected through the wires of the internet cables worldwide. For example, AWS has a different region. One is in Frankfurt. Right now I'm in Germany, so I use Frankfurt one. Okay, so and the second stuff is how the pricing is actually impact on that, which is great. So EC2 is nothing but you need to create a system. When you create a system, Amazon gives you predefined a Windows operating system or Linux operating system, and some software are already configured. So you just click on that, and then you can actually create a machine. But the thing is that these machine can be the good thing of the using cloud, it is elastic. What does mean by elastic? Elastic mean elasticity. When you stretch a rubber band, it expand. When you release it, it contract. This is elastic. So elastic means that when you need more resources or more user, it automatically expand. When there are less number of users, you don't pay for a much bigger size of any computer power, but it's shrink down. So which means that your laptop, for example, normally don't do any elastic stuff, but this is elastic. So there are a number of different actually benefit of using EC2 instance. EC2 instance is a very core concept. This is the computation power, which is scalable. There are different billing options. We'll discuss into the deeper depth that what is the pricing model of the AWS, which is very important. Elastic load balance is very great, another benefit, and it provide you SQS and SNS is nothing but yeah, this is a queue service where you can for example ask your computer to do 10 different tasks but queue them one by one, and it try to pick one in second and third and fourth. So this is concept of queue SQS, and SNS is just nothing but notification servers. For example, for every finishing up every single queue, it gives you a message on your phone that I'm done. Well, so there are different concepts of that, as I have told you. There are different stuff within that compute. One thing to notice that this is client service model, server model, not very important. Client means that you request something, it is do something. Great. Then this is the logo of your EC2 instance always. And the good thing is that when you open it, it's boot like simple machine very efficiently because it's already has two module. I don't want to go into the deeper detail, but it is hyper virtualized system based on the hardware stack. There is a hardware and then a virtualized stack where they have all the things in the image form, like the AMI image, and with pre-installed software, it's very easy, just matter of internet connection to load it. So installing all those stuff is very faster. I will show this on Amazon console as well, how you can do it, right, and how you can stop it. So there are different type of instance, micro or some other large micro X2 based on different stuff. You can do different stuff. So this is some example we are not interested in. I already have told you there are different type of instance. General purpose means that suitable for a small work. Compute compute optimized mean that you need a lot of computer resources like big application and stuff. And some are the memory optimized where you need to store a lot of data. So there are different, there are always different use cases. And accelerated computing means that your hardware, networking bandwidth, and these graphics workloads are very important for you. Storage optimize always mean that you also need a lot of storage. Great. So here's the matching puzzle we can do. For example, if ideal for the high performance database, might be it is memory optimized, suitable data warehousing, where you need a lot of storage, you need storage optimized. Balance means general purpose. Okay. High performance processor means a lot of computer power is B. So as you can see, yeah, that's that. That's how you can do stuff. Let's come to topic C, that pricing model. Pricing model is kind of, you know, three models: on demand, right? On demand, spot, and reserve. So what does mean by these all three? So on demand means that you just reserve any instance, and based on the load, it's increase the price of stuff. If your load is increasing, it's automatically upscale, like make it bigger, but the cost is more. So on demand means that then when it's more user, more money, less user, less money. This is kind of bit expensive too, but it is normally for the enterprise people who need on demand. Then AWS has another model. So what they do is that at one time in one region they don't have too much number of users, and what they do, they go in the auction or the big bid style. Bid style, for example, Amazon has 100,000 idle EC2 instance. Nobody is using them. And what they do, they create a small pool of it, and they create a bid price. And bid price means that on the market demand and supply, for example, they say that, well, we have some idle or not working or not in use EC2 instances available for rent, and you just place your bid. If there are a number of more buyer, the bid gonna increase. Either you have to increase your bid, or your EC2 instance will interrupt if if the price of pool goes higher. So this is kind of this is only for a short time or temporary kind of resources. It's good, otherwise it's not very good. And if we talk about the reserve stuff, well, great. The reserve is that you reserve something specially for some time for you as well. So you say that please reserve this instance for me, regardless if there is a user or not user. If I use it, if I don't use it, but please reserve it for me only exclusively. And it is a little bit cheaper, but again, the price could vary. There is another model or another type of instance actually for Amazon, which is kind of you know um, which is kind of dedicated, which means that it's exclusively for you, and it's a real on infrastructure level. This is physical computer sitting somewhere in an Amazon warehouse, and they reserve your physical laptop for you. No virtualization, nothing. Well, Before we go to the question answer or practical question session, let me just tell you that how it look like here. You can go to the dashboard or services or whatever services, or here you can always see that EC2. Well, that's how it look like. If you go to the EC2 instance, there are different option always, comes up. For example, instance type. There are different instance type for the AWS, T micro, T nano, and whatever it is, medium, large. And yeah, there are different EC2 instances, right? So you have also large template, which means that pre-built stuff. This is support request. You create a support request and you configure that which kind of stuff you need. These are the machines for window operating system, server, whatever your need is, right? And the capacity like 10 instance you need, right? The VPC or virtual group is default, number of CPU need and everything. And this is the price strategy. Price capacity optimize or capacity optimize, like price wise optimize or capacity wise pool. And then they charge you based on the instance. This is one thing. Or you can always launch dedicated one, which here dedicated host. And reserve means that you reserve it for purchase it for reserve for some time, right? Here if I go here and I say launch instance, right, and I say my first instance, and then additionally you can also tag it. For example, you can add new test that uh, for example, you say that course module 01, and then you can here if you need this is standardized Amazon Linux one built by on top of Linux. They built their own. As you can see that if you sign up for you sign up actually for first time and you enter your credit card and everything, then they give you a free eligibility tier, and this instance coming up free. A lot of stuff coming up free. If I browse all the list of IAMs, and it's gonna tell me, if I say that please tell me only the free one, or please give me only the Linux one, or please give me only 64 3-bit architecture style of the board. And on the free tier, it's always written free tier, right? You can always see that this is, kind of always micro. If you select it, it's gonna give you some stuff already. And it says you that it is on demand SUS basic price, but it is under the free tier family, and T2 micro is the generation. And here you can always create key value pair. What is the key value pair? Key value pair is always necessary to access your machine outside from your network with key value pair, which means that this key actually private key you always have, and public key you need to install on SSH server wherever you're accessing it from. And then when you supply private key, it always access it instantly. And you always can generate this instance here, right? There are different method for creating PIM key. So I can say that module 1 key in PIM format RSA is good, and I can generate key value pair, and I can save this somewhere, for example here, right? And for network, there are different type of network. There's VPC, virtual private networks, and inside virtual private network you have subnets, and you can create multiple subnet. We'll discuss the complete stuff. We can always create a security groups, and in the security group, we can assign security groups. For example, if I have created a policy for any specific security group, I can assign all to my group so that whenever it comes to that groups, it is able to access that. So we'll discuss it in the security module in greater detail in IAM role, policy, and everything. But right now we can just say it as it is, leave it as it is. Well, now comes to storage, and we can always add some volume which is freely available here, like 8 GB 1x. We can add it, and we can say launch instance, right? For example, if I launch instance and it's gonna take some time, and well, then it's when I come to instances again, it's gonna show me my instances here. Maybe if I refresh it, then it say this is your first instance status pending, because it's not. If I here click on the action, there are a lot more setting for the instance. So stop it, change the resources, change the tag. There are many options for networking. There are many options. RDS is the external RDS, when you can connect it from the RDS database. No, the RD, this is not RDP, sorry, this is RDS database. You can even connect your instance from the RDP with your key, whatever we have key here, and there are different image. And that's gonna be Linux machine in the end. If you click here, it's gonna give you the IP address of that machine, IP4 address, IP6 address, and this is actually the domain name server. By default, it's this domain name server. You can configure it to your local domain. For example, if you have some website, you can somehow create a website as well. So yeah, that's that. Perfecto detecto. Um, that's how you create instances, and that's how you terminate them. If you need to, you can click here and terminate if you don't need them permanently, and it's gone. Yeah, this is the concept of instances, and then we gonna ask some question later on, practice some questions and answer of them. It is better to study this. Okay, let's see some practical question here. That, for example, what is the primary benefit of using reserve instance compared to the on-demand? Well, if we compare these two, there is a cost-saving option always there, because for the Amazon, it's always more predictable income that you reserve it for 2 years, and they know that you're gonna pay them for 2 years, and that's why they offer a lot discount. So this is the benefit, which means that this is the right option. Um, which EC2 instance price model should you use if you want to avoid a long-term commitments and need instance that can be terminated on short notice period? So for answering any of your question, you always need to first highlight the keywords and important keywords. Then you can always, so this question is about pricing model first of all, and second thing is that the instance which can be terminated on short notice period, and there is no long-term commitment. So these are three features of this question, and these all features actually gives you indication that it is spot instance, right? And what is the saving plan in the context of EW2? So again, a plan that allows you, commit to consistent amount of usage for a reduced rate is the saving plan. Means that consistency in the usage wise is good, and price wise it's low. When these two features are available anywhere, this is, you know, A plane that provides access to dedicated, this is for reserved resources. A plane that offers reduced price and unused capacity, no, this is not load balancing. So a plane that reduced rate but the commitment of the consistent amount of users, these two feature, number one feature and number two feature, both of a good price feature are there, which means that it is the option. So great. So let's now see some other topic, which means that what is auto scaling and load balancing in the Amazon. And let us also see how they works in world of console in real time. Okay, next important topic here is that auto scaling. How? So let me just before we go into the deeper detail of that, let me just tell you what is meant by the scaling and balancing. I mean, these are the two concepts which we need to always keep in mind, right? So the concept of load balancing means okay. Let's first the auto scaling. Auto scaling means that there is intelligent system or the way created by or drafted by the AWS, which when there is more demand or more user for any services, it's automatically increase EC2 instances in the background. And when it increase more resources to that pool, it's gonna serve more people. For example, if 100 people access the website, or if 1,000 people access the website, it increase and decrease automatically. This is actually auto scaling. But on the other side, load balancing means that number of requests, what incoming request goes where. For example, you have 10 PCs or 10 computer or 10 EC2 instances increased as per number of like 100 requests from the 100 user. But let's say like that, for example, in 1 minute there are 50 people access the website, but these requests actually of those users are only going in randomly 5 PC or 5 computers or 5 EC2 instances. Now the thing is that all other PCs or instances are idle, are not using or unused, and the load maximum 100% load on couple of computers or EC2 instances, which actually is not a good example of load balancing, which means that you must have any idea to load balance very equally. So anything that is distribution of the load or the workload, uh, anything that deals with that is balancing, load balancing, and anything which increase the number of computer is the scaling. So these are the two concepts. For example, how you can increase the capacity, for example. Great. This is the example that you increase this when there's more traffic, you add more computer here. Right, and the load balancing again, that how you distribute your work. And this is the load balancer, which is responsible actually for automatically distribute traffic. For example, any traffic which is coming from the outside world in shape of user who are calling the website, for example, first come to this load balancer, and this load balancer distribute work equally to the different PCs. And so here you can say that at low demand, every traffic first comes to these people, and then load balancing, and this automatically gives to them. And on this level, there is the auto scaling group, which is responsible. So this is the symbol of auto scaling, which is responsible based on number of requests. It's increase or decrease the PCs. However, the elastic load balance is based on number of requests automatically distributed equally to all the PCs. So that's the stuff. So for example, there are 1, 2, 3, 4, 5 users, and it's give one user to each computer. It's great. What is not example of the good load balancing is that there are two PCs, but it's automatically distributed actually 2 or 3 or 4 and 4 to this computer and only 1 to the other computer. Is not a good example. of load balancing. Great. Here it says that please give us which one is which. For example, remove the unneeded Amazon EC2 instance when demand is low. This is something increasing or removing the pieces. It is the scaling. Distribute the work across different people is the balancing, load balancing. Automatically adjust the number of EC2 instances, something that deals with increasing or decreasing the computer. It is again scaling. So add Amazon EC2 instance during the online store. Scaling. Ensure that no single EC2 instances carry full workload is balancing. And provide a single point of contact for the traffic into auto scaling group. I guess this is again scaling. So yeah. Great. That was load balancing, not scaling. That was wrong. So yes, so that's how actually stuff works. And how services communicate with each other. Normally they communicate with the help of SQS or messaging services, that is SNS. One service can easily send a message to the other service, and based on that message, it can. So that's how actually services at the AWS works with each other. That is the old style of the application when there was not cloud. Every whole application is containerized within the one main container, but nowadays every application works like independent component, and component can talk with each other. This is the simple, SNS services where you can create a subscriber of any topic or publisher of any topic. This is robotic style publisher subscriber, mostly used in the robotics industry. This topic publication and subscription module, similar fashion, they create some message, and that message is subscribed by the service, and this service can work so that they act upon. So great. For example, with queue message sometime in the SQS, and from the SQS this message get picked up and to fulfill the order. Yeah, great. And there is one component of this serverless computing which is Lambda. And serverless computing again under the computing, cloud computing, which is the service well renowned right now. What Lambda does is that in background only Amazon knows that which computing power you need to give and how many computer you want to give. You just you know I can show you later on how Lambda works, but simply actually you open the Lambda, you go into the Lambda, you've configured the software stack, for example Python or whatever you needed for it, and you start writing. And everything in the background is serverless. You don't know the server, you don't know how much resources, you don't know how much capacity, everything is automatically done, and your application is beautifully running. And this is very well renowned. Serverless computing is one of very much key aspect which make the cloud services well renowned, and many people are shifting towards. I will show you what I mean by that. You just upload the code and some application is running in the cloud. Amazon Lambda, as they mention it, this is the Lambda symbol. Without managing any server, you don't need to worry about anything. Code is triggered automatically, your code is talked to any kind of service anytime, only whatever uh, you use, you pay on demand model, the HTTP server. So a lot of good stuff. And similarly, this container is similar to Docker container again, your containerized service. For example, you have one container where there are a lot of different stuff is working on that, on the top of container. So the beauty of these container is that they're reproducible within the second. And if one container goes off, it's immediately create a clone of another container, which means that you just change the IP address in the background, and the new container with new services and new everything is ready. And this container is kind of stuff this could work anywhere. For example, let me just give you the example of container why it is very important. For example, in the previous days, 1 decade ago, you're sitting on your computer, you have done something, you install a couple of modules, and your application is working beautiful on your laptop, but you want to ship it or you want to give it to your customer or anybody, the owner of the product. Okay, please see what I have developed. And when you give it those packages, he download these packages on the computer and say, okay, nothing is working for me. How you have configured this? Might be say, okay, why? Might be I have Windows computer and you have Ubuntu computer or Linux computer. Might be I'm using a different technology and you're using MacBook and I'm using Windows. And somebody would say, okay, might be, the package you have downloaded has different version and I'm downloading is a different version. And might be there are a lot of stuff that person has to do. Okay, do you have Python installed? And then person would say, okay, no, I don't have Python. And you say, okay, please install the Python, but make sure that you install version 3.0 or 3.x. So there are a lot of problems. You see, whenever any developer develops something and when it's shipped to or show to some other person who's a stakeholder or responsible, there's a lot of problem. So then people come up with this containerized stuff. Containerized means that everything you have done here is shippable to anywhere. It's using its own serverless virtualized stack. This virtualized stack is just talking to the lower level of computer resources. And on the top layer, whatever you have built is shipped or containerized into the environment. And you throw it anywhere on Windows computer, on MacBook, on Ubuntu, on Linux, whatever, and it's going to work beautifully. And the person who is testing that thing not need to do anything. So that was the concept of container. And Amazon is also giving you container service for sure. And it's also give you elastic container server actually, which is nothing but similar to EC2 instance. This is the stuff with a lot of Kubernetes container. EKS is the server name, and you can manage, you can create a containerized application, and your container automatically scale up or scale down. So that environment has a lot of, and this is the container server service logo. And one any container and any PC or computer within the container or the Docker container is callable with API or with IP addresses. So the scaling is no problem, the upgradation is no problem. So a serverless container, you don't know what this is. This is a Fargate. Run serverless container with AWS ECS. Container services pay only for the resources you. Elastic container services is nothing but it is very similar what load balancer autoscaler is doing. While autoscaler is for EC2 instance of the normal computer, but this is elastic container services for ECS is for containers. It's increase or decrease the container, and otherwise is same. What is EKS? EKS is the Kubernetes cluster. Kubernetes is a very specific kind of technology which containerize actually the which containerize actually Docker's container. The different number of containers can get together in one cluster, and this cluster is Kubernetes cluster, and it's work with pods, and these pods actually are accessible. And there is one server which could create in the background a different container, on top of the container different clusters, and on top of cluster there's different ports to access it, but very similar what Lambda is doing, similar fashion it's doing with serverless computing fashion, where you don't know that what it is doing and how it is doing, but it is completely managed for you. All the infrastructure is managed for you, all the containers are available for you, and you don't have to worry at all about anything. So let us see how it's look like. If we go on the EC2 instances dashboard here, we click here and we can always see the load balancing. Well, to load balancer, we can create a load balancer. Which kind of load balancer we have? Do you want to balance your node of based on network? If there's too much networks, allocate on different sources. Or it is load balancing of application. For example, you run some application and this application is accessible with HTTP. If there are more users, you can create it from here. Either you can also create it from the classical load balancer, which actually increase, classical style, which increase more computing power with EC2 instances. So there are different options. Everything has its own pros and cons. You can create from here. Auto scaling groups, you can always auto scaling group. So this group means that this helps you maintaining your size. You can say that this is my maximum size I can go up to, and my test scaler. You can also select any template. There are many templates available. No template is here, but I don't know why. But normally there's templates. And then you can always tell it that how much number of thing, how much the scaling size I need, blah 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 blah. And since I don't have any template, I have to create the template, and template means that I have to add number of different instances in it and stuff like that. For example, I have to create here the template with help of EC2 instance, which means that, for example, which kind of computer you want me to increase when it needed. Can I just add any random computer to your scaling, or you need any template? It's always a better idea to first create a launch template. Launch template help you to launch some fixed stuff. Here I can also set up it to the guidance where I can say that please, this is the part of auto scaling, and I say please get this computer. Always give this key value pair to this computer. Save this instance, right? And it's also part of EBS volume or not, and create launch template. When you create launch template, this launch templates appear up to your EC2, and in the end you can see it, right? And in that region where you are working, you can actually come to the dashboard, auto scaling again, and then create auto scaling, name it whatever, and the template you have created should appear here. You select it. Next, you say some option here, advanced option about notification, where it gives you notification, and done. Then whenever your more traffic is coming up, it's automatically create this template or this kind of launch template what you instruct it to do. And this is a beautiful thing. So very quickly, we have covered a lot of stuff by now, which means that we have covered EC2 instances, we have covered scaling, we have covered load balancing, in this similar fashion. Okay, we have talked about load balancing as well, and then we can talk about so forget elastic Kubernetes cluster. We can talk about elastic container. We can talk about. You can come here. You can always add some cluster, whichever cluster you need. You can create. You can register. Well, the version of cluster, some role you can attach to it, that what these computers can do, configuration map you can give them, and then networking you can say that okay, this VPC please add this VPC to this zone availability and observability. This is the add-on if you want to add something extra, and in the end it's create a cluster for you. And if you configure a forgate, it's gonna configure forgate for you. Now let's see some question here. So for the load balancing and scaling, what is the primary function of the load balancer? The primary function of load balancers is always to distribute traffic equally. So this one is the answer. What does auto scaling helps you to achieve? It help you to achieve that you automate the balances load of instances, right? Then which AWS service should you use automatically? Just EC2 instance base. It's auto scaling, right? It's auto scaling because it's a EC2 instance based on demand. It's automatically just the number. Whenever this number, this is balancing. Okay, what type of scaling policy allow you to maintain specific metrics such as CPU utilization? It's a target tracking scaling, right? When it comes to this thingy here, which AWS service provide you fully managed Kubernetes control panel? Great, it is EKS, Elastic Containerization Service by Amazon. EKS. What is the primary benefit of using AWS with ECS? With Elastic computing power. It's give you ability to containerize your application without worrying about underlying structure or infrastructure. What is the compute engine? What type of compute engine is AWS Forget classified as? So it is similar as I said. Lambda use EC2 instances and containerized application use containers under the hood, but it is again serverless. How does AWS ECS helps container orchestration? Well, great. Orchestration is auto scaling stuff, and it's actually allowing you to scale Docker container within your application. That's how it's help you because it's Elastic service, and that's how Elastic Container Service is meant to. And yeah, EKS is Elastic Kubernetes Services, and ECS is Elastic way to manage it. And Forgate is the combination of serverless stuff. You need to just mention it that I want to work with, container, and it's do stuff for you. So that was module number 2. We can also go into the greater detail of module, but I think so. Well, from next year, actually, we'll discuss this cloud practitioner, global infrastructure and reliability stuff. And then we'll discuss more important networking and storage so on. So thank you very much. To the next session is that module number 3.